Okay, let us now begin on exam-based practical 7. Okay, let's look at exam-based practical 7. So the first one is a simple titration. Okay, titration of what? Sorry. Let's zoom in a bit. Sorry. So the first one is a simple titration of sodium hydroxide with HCl. Okay, so now the idea behind it is that you are diluting Fa2, okay, and you fill up the burette with, after that you fill up the burette with, let's see, Fa3, hold on now. Okay, Fa1 is inside the conical flask, so the sodium hydroxide in conical flask. So you must ask yourself for which one is inside the conical flask. Conical flask is now in Fa1, which is the base. Okay. Then for the burette there, you actually have your Fa3, which is diluted from Fa2. Diluted by how much? Diluted by 10 times. Okay, if I ask how do I know it's diluted 10 times, so it's very simple only, because your Fa2, right, you got 25 milliliters. You make it up to 250 milliliters times 10, so you diluted it by 10 times. So the main idea is that you know what is your Fa1 already, because they already tell you the mass that's dissolved and things like that. You do not know what is your Fa2. So it's right now, what's the confusion part? The confusion part will be right here. What is HCl concentration? This one you do not know. Okay. So remember, burette is the acid, conical flask is the base. Conical flask, you know the amount. Okay. So I won't go through much of this. It's pretty standard. Volume of Fa3 at the initial final burette reading. Okay, now first thing first, please do take note that you need to write out your mean theta. Let's just say they are the same value, 24.95, 24.95. Should you write this out still? Answer is yes. 24.95 plus 24.95 divided by 2. Also should write 24.95. Even if they are the same value, please write out the working. Okay. Now, what's the first one? The first one is actually calculate the concentration, right? This one is a variation because in Fa1, they let you know what is the amount, but they didn't tell you in moles decimeter cube. They tell you in grams per volume. So you need to change the grams per volume, right, into moles per volume. So how do you do that? To change from grams to volume to moles volume, divide by the molar mass. So this is the molar mass of NaOH. With that, you're able to find the moles per volume, moles centimeter cube of Fa1, which is the sodium hydroxide. Then after that, from the moles decimeter cube already, you able to times the 0.0250. Please do take note that your base is in conical flask. Your base is in conical flask. So 0.0106 times 0.025. 2.650 times 10 negative 3. Here usually I give about 3 significant figures. Now, moles of HCl mole equals to moles of NaOH. It is because it is a 1-to-1 ratio in the stoichiometry. So therefore, the moles of NaOH and the moles of HCl in the burette is the same. Okay, then afterwards, to find the moles of F in Fa3, right? Do take note, this 0.025 is not from your this 0.025 is not from your conical flask. This is actually measured from the burette. Therefore, you get 0.106 in FA3, which is diluted already from FA2. So therefore, when I want to find the concentration of HCl in FA2, I times 10 because that is the amount, that is the what we call the dilution factor. So I times 10 get 1.060 moles per decimeter cube of Fa2. Okay, so this is another standard, this is also another, now number 2 is a style of standard question where you are collecting the gas. So do take note that in this particular question, what happens is that you are finding the volume of gas. Most of the time, right, this type of question, right, it will start from like this. First, you go from number 1, volume of gas. Number 2, from volume of gas, find the moles of gas. From the moles of gas, then you're able to find the moles of usually the carbonate compound, because they will give you the equation. So for example, this is a 1:1 ratio of the carbonate to the carbon dioxide. Sometimes they may ask you to find M, sometimes they may ask you to find some other things, but usually that's the way it works out. You from the volume of gas, you find the moles of gas. Then from the moles of gas, you go backwards. Okay. So standard. So you find the mass of container. Please do take note, must always put the grams, must always put the units so that you can find your final volume of gas collected. 127, because the measuring cylinder is 250. So in the 250 milliliters, right, it's actually always plus and minus 1. Okay. Okay. Now, how does this formula work out? Please do take note that 127 is 127 centimeter cube. You divide by 1,000, right? Because you want to change it to decimeter cube. 1 mole of gas occupies 24 decimeter cube. So 127 over 1,000, how many moles occupy is it? So the moles of carbon dioxide gas will be 5.29 times 10 to the power 3. Looking at the question just now, what's the ratio? The ratio is 1:1 ratio. Therefore, the moles of carbon dioxide and moles of M2CO3 is the same. Now, after that, right? After that, right, what happens is that you have 0.90. Why is this 0.90 leh? Because this is 0.90 is the mass of the carbonate. That's the mass from the carbonate. That's why initially you have the mass of Fa4 minus the mass of the empty container. Because you want to find out the mass of the carbonate before you reacted. Okay, 0.90. Over the moles of the metal carbonate, you get 170.1. Remember, you still do not know what the metal is. So 170.1 minus 12.0 minus 3 times 16, because this represents the CO3. So you need to minus that out. Divide by 2 because it is M2. So need to divide by 2 to find the atomic mass of M55. The closest to it is manganese. So what if let's just say you have something closest to it like potassium, sodium? Always follow your experimental value. Always follow your experimental value. Okay, so for this particular type of question there, don't worry about the supervisor. The supervisor value is always more lenient when it comes to the collection of volume of gas. Oh, this one doesn't have the percentage error. So for this one, right, for the percentage error, right, because you only read it one time. So you must remember, you read it one time, it is 1 over. What's the volume just now? Hold on. The volume that you read just now was 127. 1 over 127 times 100%. And that's the value you put inside here. Okay. Okay. Now, it is likely that the volume of carbon dioxide collected was less than theoretical volume. What does it mean now? So let's just say just now, what did I collect, right? Is I collect the actual one. I collect the actual one to be maybe about just now, sorry, 127 milliliter or centimeter cube. But the theoretical one, maybe the theoretical volume, right, is theoretical, right? You are supposed to able to collect maybe, I'm just putting a random number here, let's say 150 milliliter. So what are the possible scenario that all the CO2, right, all of it, right, like let's just say it's all 150 already. You don't see all the 150 in the measuring cylinder. One reason there is some of the CO2 reacts with H2O. Carbon dioxide can react with H2O to form carbonic acid. So therefore, how do we fix this there? Instead of measuring via displacement of water, remember for that particular case, your volume of gas is collected over water. When the gas passes through water, some of the carbon dioxide could have dissolved or react with the water to form carbonic acid. So instead of measuring via displacement of water, or instead of measuring the gas through water, right, recommend just connect it to a gas syringe. Connect it to a gas syringe. That means don't go through water. The tube, right, goes all the way to a gas syringe. Okay. Now, what is the second reason? No, you do not form you do not get out. Let's just say assume 150 milliliters of carbon dioxide. You're slow enough. When it comes to this sort of experiment, right, you must remember, you need to be faster. That's why I say when you pour, right, straight away must close ready. Because if you allow it, right, gas escape, right, you cannot collect the gas. Okay, so one of the reason, gas escape because let's just say you're too slow, you didn't quickly put a stopper, gas escape ready. What does this modification is? Use more of lower concentration of acid. Okay, what does this idea means? Acid lower concentration. That means less carbon dioxide form. Less carbon dioxide form there. The amount of carbon. I mean, you can still use the. You can still use less carbon dioxide form. Let's just say. You can use the excess. Let's just say you use excess. You can use excess. Just that. Let's just say per minute or per second, the rate becomes slower. So what happens is less carbon dioxide escapes per second, let's just say. So you can use excess acid, but you just make sure the concentration is lower. Concentration lower, rate of reaction slower. Rate of reaction slower, the amount of carbon dioxide formed per second become lesser. Less carbon dioxide escapes per second. That's why they suggested this. Okay. All right, now come to qualitative testing. Okay. Now this one very straightforward. I want you to always remember when you see the thing sodium carbonate, no need to think already. You are definitely forming like effervescence. So for this particular Fa567, right, they're all organic compounds. Okay. Okay. So the key word right here, right, let's just notice is carbon, hydrogen, oxygen. Okay, so I want you to think about it. Carbon, hydrogen, oxygen. If carbon, hydrogen, oxygen, right, you only got a few potential functional group only. Alcohol, aldehyde, ketone, carboxylic acid, ester. So these are the possible potential one. Because these two reacted with sodium carbonate, Fa5 and Fa6, they will have high chance they are carboxylic acid. Okay, silver mirror form. That means so what happens is a silver mirror can only form with aldehyde here. Actually, no, sorry. Actually, this one is a bit old already lah. There's one type of carboxylic acid that can react with aldehyde. Okay, sorry. There's one type of carboxylic acid that can react with this. Can react with this Tollens reaction. That's why this is a bit old lah. And this one is aldehyde. Decolorizes purple color solution. That means oxidizes. Okay, so this one didn't oxidize, makes sense. This one oxidizes, makes sense. Aldehyde can be oxidized. This one there, okay, so this one, right, is no change. It's confirmed not aldehyde already. Okay, confirmed not aldehyde here, and yet it decolorizes purple color solution. So the only answer for this is alcohol. So Fa5, Fa6 are both carboxylic acid because they are the only one that can react sodium carbonate. Fa7 is alcohol because it oxidizes but it doesn't undergo Tollens reagent. Fa8 is aldehyde because it reacts with Tollens reagent. Okay. So Fa5, Fa6, carboxylic acid. So carboxylic acid, aldehyde, redox reaction, alcohol. Now, we say that Fa7 confirm the presence of the functional group. So just now, for Fa7, right, we say that one is alcohol, right? So what else can react with alcohol? Another one can react with alcohol is, do not carry out this, sodium metal, which will form the sodium ethoxide, and you release, if let's say ethanol, it will be ethoxide, but we don't know the alcohol. But the alcohol will form the corresponding anion. This one will be the hydrogen gas. So sodium metal will react with alcohol and release hydrogen gas, which will pops with a lighter splinter. Okay. Now, if you look at this carefully, so this one, right here, right, this one is based on your observation skills already. But because of this one, add sodium hydroxide and aluminium fluoride. This is testing for nitrate or nitrite. Both also forming ammonia. Nitrate, nitrite, they both also form ammonia. So the only way to tell the difference is this is an O1 where they react with HCl. This is to make it easier. I think they have you react with potassium permanganate. This says they didn't want you to react with HCl. This is an older syllabus lah. This says they will ask you to react. So for the more modern answer is add acidified potassium, acidified AmNO4. Okay. And then from there, you decide that if for those that didn't decolorize one, that will be nitrate. The one that decolorizes one, that will be nitrite. Both also didn't decolorize one, then both also nitrate. Like that lor. Okay. With that being said, thank you.